Hello everyone. Today we are going to perform a case study on partial differential equation. For this we have chosen heat distribution in a metal rod.
For this we have chosen a metal rod of length L. So we have to find the
heat transfer. So what they are doing here is they are trying to understand the heat flow or heat distribution from a vertex, maybe like from A to B. Okay, let us assume, right? So we are going to understand the heat transfer. So why we come across partial differential equation here? The reason is partial differential equation is a kind of approach which talks about rate of change. Right? Rate of change. Here we are going to talk about distance, and here we are going to talk about time. If the differential equation is depending on more than one independent variable, then it is partial differential equation. Right? It is partial differential equation. So that's why we are working on partial differentiation here, and here we are going to talk about the heat flow. Heat flow, and I was telling you heat flow is a type of partial differential. We have different types of partial differential equation, like wave motion equations are there, heat flow equations are there, then maybe liquid flows you can take. So in that they have chosen heat flow equation. Okay, what you are trying to do here? What you are trying to understand? What you are going to understand?
so distribution of heat from point A to point B with respect to distance and time.
So where you see such kind of scenarios in industry, right? In industry you can see big boilers, very big boilers you have. So it has to withstand more temperature. Maybe you can take an automobile, you can take an engine which withstands the high combustion that is happening inside the engine. Right? So in that level, the thickness of the material and also the particular type of material to be chosen so that it withstands the temperature distribution. So what they try to say here is partial differential equations can be used in heat transfer distributions, and they can understand how the flow happens, how the flow is happening with respect to, maybe if I take here, maybe here distance is maybe 5 centimeter. So you can even check that maybe I am 5 centimeter or 5 kilometer or 5 meter, whatever the distance, at a particular time, how much temperature have been distributed, how much temperature is distributed, maybe after next 15 minutes, after 15 minutes in this particular distance, what is the temperature now? So likewise you can understand the temperature variations. Again, where it is useful in combustion areas, it is useful in heat involved areas. Am I right? Because in engines we very much specific, we are very much involved in understanding the heat withstanding capacity of the engines. Am I right? Suppose if the proper metal is not used, we will understand the heat distribution happening in it. What will happen? The metal might melt. Am I right? The metal might melt. Am I right? Metal might melt. So you have to understand the withstanding capacity of the metal. So accordingly they might use. So this is, for example, if you take a aircraft, or you take a maybe we can take a rocket launcher, whatever it is. So when rockets travel into the space, it has to withstand high pressure. Am I right? High pressure, high temperature. So accordingly, the plates over that structure will be fixed so that it withstands the temperatures. Okay, it withstands the temperature. So it's a very good application. This is a very good application of partial differential equation when it comes to our day-to-day industrial area, because you can see what you have stated here, that is heat flows from high temperature to low temperature. We all very well know. So we are trying to see how the flow is from high temperature to low temperature, and also they can find the gradient for it. The fundamental idea of differentiation starts in finding gradient, dy by dx. That is the fundamental idea which you have started from 11th standard. In 11th standard they taught you dy by dx. dy by dx is nothing but finding gradient or finding slope. That is the base level of partial differential equation, from where the entire world gets the next level of the differential equations. Okay, so where started this partial? It started with finding the gradient. Okay, then next level improvements according to the requirement of the real life application. application. So you can see here in cooling systems, in engine thermal management and heat, heat sink design or industrial furnace reactors in various, maybe you can talk about even this thermal power stations. Am I right? Thermal power stations, even there they need such kind of temperature distribution analyzing area. So thank you for listening.